and what it says. Let's see. Hi everyone, welcome to the Pandit Madan Mohan Malviya National Mission on and Teaching, the teachers and teaching. This is the second in series. The last one was in June 2021, and this is February 2022. And in this, we have experts who bring their knowledge and impart to the faculty and the research associates. So this is the part of that, and here we have uh, Sriram uh, Rupan Gunta, who is the co-founder and SVP engineering of Arna Networks. Arna Networks is involved in what you call engineering effort from here, as well as with Amar. Uh, Both of them are co-founders, and Sriram heads here the technical engineering aspects, and he has been involved from beginning on the ONAP, and additionally his background comes from an embedded side from Western Digital, and prior to that he was involved with the startups and all that, and which were acquired by Western Digital. So he has an excellent background, and I believe that is the Emilex I was referring to. And he lives in Bangalore with his wife and a daughter, and he has a bachelor's in WE from IIT Chennai and master's in communication from IIT Delhi. So he has a double IITs, very interesting. And he is also a specialist in enterprise technologies. And obviously, I know that he has done something in the data center previously. So we are going to have a full 1 hour of engagement with him to go over the topic. Go ahead, and the topic he will describe. Go ahead. Welcome on board. The floor is yours now.
All right. Hello, everyone. Thanks, Prakash, for the introduction. So today, the topic that we're going to cover is cloud native and ONAP management tools, for especially for 5G, OSS, BSS. The agenda is on the right-hand side of the slide. So essentially, we'll start with some introduction to the cloud native systems, the role of containers, Kubernetes, and so on. And then we'll have a little bit of introduction on the ONAP. ONAP has two components, design and runtime. So we'll talk about both of them. And then we'll talk about what is OSS BSS, where does it fit in with ONAP, how does it interface with ONAP. And then we'll talk about ONAP's journey for the telcos. So that's where we'll be focusing on. There are other use cases as well, because ONAP is not only for telco, but we'll walk through all the use cases with more focus on the telco use cases. And lastly, we'll talk about what we have done as in Arna Networks to harden ONAP for commercial use. So we'll have 1 or 2 slides on that. So that's the agenda for today. So with that, without any further delay, let's jump into the presentation. So the first few slides are just general introduction. Some of you may be already familiar with it, but let me go through it for the benefit of others. So first of all, what is network function virtualization, NFVs, right? So essentially, there is a transition that's been happening where people are moving away from dedicated hardware that provide fixed function services to a virtualized world. So that's the transition that you see here in the slide. So earlier, every box used to have its own service, firewall, router, switches, and they all used to be connected. So there's a lot of manual management required, multiple interfaces, multiple tools, and there's no practical way of doing dynamic services. That's the most important part. So if you want to change something, you have to rip off some of these and then replace with something else. So it's not very easy to change. So from that, the world is moving to more virtual world where the hardware remains the same, and then you build a virtualized layer on top of it. And they could be virtual machines or containers. So we'll talk a little bit about both during the presentation. So essentially, the whole idea is that the entire setup is going to be agile and it's on demand. Right? So, and the other important part is that everything is automated. So in fact, the entire ONAP project is about automation. So we'll talk about that as well. And in terms of terminology, just to make sure we are all on the same page, we refer to XNFs in the presentation. So what we mean by that is VNFs, CNFs, and PNFs. So the VNFs are virtualized network functions. So these are typically virtual machines. So you build them as a VM and run them on the hardware. CNFs are cloud native or containerized. So they are much smaller in footprint, and there's a lot of move from VNFs to CNFs these days. And lastly, PNFs are the physical functions, because there are always some functions which are going to be physical. For example, in 5G, the radio is always physical. You cannot virtualize it, right? So the antennas. So those will remain as PNFs. So the important thing is that all of them can be managed in this framework that we're talking about. So another introduction is the reference architecture that you might have seen it in some of these HC presentations. So again, just from a terminology point of view, there are three layers that you can think of. So one is the NFVI or NFV infrastructure. So this is the infrastructure, service, servers, storage, switches. So this is the physical infrastructure. And then you have hypervisor running on that to provide the virtualized infrastructure. And then the layer that we are going to focus mostly today is called MANO, MANO, management and orchestration. So this is the layer that you see on the right-hand side on the diagram, which manages the NFVI and XNFs that we just talked about earlier. There is the NFV orchestrator, where you can orchestrate, you can place them in different clouds and so on. And then the virtualized infrastructure manager, or the VIM. So the VIM is the layer that you see at the bottommost box on the right-hand side. So that is the layer that manages the virtual infrastructure. Right? So there is a clean separation between the layer, the software layer that manages the virtual infrastructure, and the virtual network function managers and the NFV orchestrators. So those are the three layers that you see on the right-hand side. And lastly, the actual network functions, which are called XNFs. Right? So these are the ones that actually do the real work. Either 5G or firewall or whatever you are implementing. So those are all running as XNFs. Right? So these are the three layers that you will see reference to them in the subsequent presentations. Now, what is ONAP? Right? So ONAP, we refer to it as MANO++. So what we mean by that is it's more than a MANO. Right? So as per HC standards, MANO has certain functions, but ONAP actually does more than that. It goes over and above that, right? So if you look at the wiki pages on ONAP, what you will see is that it's essentially a comprehensive platform for real-time, policy-driven orchestration and automation of physical and network, virtual network functions, right? So that's kind of the real definition of that. And again, we'll go into the details and see how it does all of this. But the important thing to remember here is it's a policy-driven orchestration, and it's essentially an automation of the physical and virtual network functions. Right? So in fact, ONAP itself stands for Network Automation Platform. Now, what is the scope of ONAP? Right? What does ONAP actually do? Right? So there are two distinct functions in ONAP. Right? So one is the design framework, the other is a runtime framework. Right? And this is very important because the entire structure and all the projects of ONAP are built on this concept. Right? So the idea is that you can do the design completely independent of the runtime. Right? And the reason is that typically the people who do the design are different from the people who actually run it. right? So when we say run, to give an example in the 5G world, right, or any telco world, people are the operators who actually instantiate these services, right? So they are essentially doing the runtime, right? Whereas design is done by the design engineers who are creating the services, right? So, you take multiple functions, you create a service, right? And then you test it. So that's all part of the design framework. And then once you're done with the design, you push it to the runtime, right? So, and that arrow that you see between design and the runtime, so that is essentially what ONAP calls as models. So the entire ONAP is built on a model-driven architecture, right? So whatever you do in the design, you create a model out of it, and then you push it to the runtime. And in the runtime, the people who are running the runtime, they may not even know how this whole thing is designed, right? What they can do is they can take this model and they can instantiate it, right? So if, let's say, one customer wants a service, they can go and click on a button and instantiate the service, and that will do whatever it is supposed to do, right? So that's the important part of the runtime, right? Now there are multiple components of the runtime which we will come into, but at a very high level, it's the orchestration, which is what is called as NFVO, and monitoring and service assurance is the second part, which both of them will cover in the subsequent slides. So this is the high level view of ONAP and where it fits in the overall system, right? The topmost layer is the OSS BSS, and that's the layer which enables customers or partners or whoever to make orders, to create billing services, and so on, right? So ONAP doesn't do any of that. ONAP provides northbound interfaces, which are typically over REST interface. And using that, these OSS BSS layers can interact with ONAP and perform certain actions. And ONAP is layered on top of the bottommost layer, which is the NFVI, VIM, and SDN controllers. So these are the underlying entities. The NFVI is the hardware and the software that is required to create the virtual infrastructure that we talked about. And VIM is the layer that enables you to control it, right? For example, some of you may be familiar with OpenStack or Kubernetes, right? So these are the examples of VIM. So that's a virtual infrastructure managers, right? So ONAP essentially is layered on top of that. Right? And also the SDN controllers. So there may be some SDN controllers like Open Daylights and Tungsten Fabric. There are several of them in the market. And again, ONAP doesn't do any of that. ONAP can be layered on top of that. So ONAP can interface with SDN controllers to do the SDN functionality. So this is the overall ecosystem and what ONAP does and what other layers do, right? And then there are some external modules and artifacts. For example, all the XNFs, the packages, applications. Again, some of them we may not have time to go into in detail, but so these are all the artifacts that typically some vendors may do it, right? So the vendors develop them, and then the telcos, the telco operators, get them, and then they onboard them on ONAP. So ONAP is something that brings all of them together, right? So that is the overall ecosystem. So in terms of the architectural principles, let me briefly talk about the ONAP, how ONAP is run. So I already mentioned the model driven, right? So the way ONAP works is that you should be able to do a lot of things without really coding or hard coding, right? So you can install ONAP, and then without writing any code or without upgrading the ONAP software, you can change the behavior. And the way you do it is by adding new models to it, right? So it's a completely model driven. The second aspect is cloud native, right? So the ONAP is completely built from ground up using cloud native architecture, right? So it's all containerized. All the components of ONAP are containerized, and it runs on any Kubernetes infrastructure. Right? And the last part of the ONAP architectural principle is DevOps, right? So DevOps is very important because in case of ONAP, it's not like an afterthought. So it's actually built using DevOps. For example, the different components of ONAP have their own CI/CD pipelines, which can be used to, do the updates and so on, and do the continuous integration and so on. Right. So that is so these are the architectural principles of ONAP. And then some of the details of this cloud native architecture, which applies to both ONAPs and the XNFs that run on top of ONAP. Right. So what are some of the principles? Right. So I will not go into the each bullet here, but essentially I'll just touch upon the high points. So they're all virtualized first of all, right? So all the functions are virtualized. They run as either virtual machines or containers, and they're all decoupled modules, and they run as individual microservices. So you can have each microservice that's working completely independently in a decoupled manner, and you can mix and match them. So, and of course, they're all open platforms. They have open APIs. So people can build applications on top of them using the standard APIs. And then there are some other principles like, you typically scale out and stuff, scale up. Right? When you need more capacity, essentially you scale out. You create more instances of that. And they're all reusable, they're secure. So these are all some of the principles of a standard cloud native architectures. And ONAP pretty much imbibes all of those principles. But also the XNFs that are onboarded on ONAP also follow the same principles. Now coming to the how ONAP maps to the HC Mano framework. Right? So I talked about why ONAP is called as a Mano++, right? So what that means is it does over and above what Mano standard specifies in HC, right? For example, Mano doesn't, the HC standard doesn't talk about design environment, right? But ONAP supports a design environment. So that's an additional functionality of ONAP. Similarly, the monitoring and service assurance are not part of the HC Mano framework, right? But ONAP supports that. And again, we'll talk about it, the monitoring and service assurance, what it does. And lastly, the SDN controllers. So that's typically outside the scope of Mano definition in HC. But ONAP supports it. ONAP has the SDN controller, which can talk to the external SDN controllers. Right? So these are the functions of ONAP that go above the Mano functionality. So this is an overview of ONAP and all the different components. And again, we may not have time to get into each and every item here, but I will just touch upon the high points. There is a design time and the runtime that I mentioned earlier. Right? So both the design and the runtime have a GUI interface in ONAP. It's a portal through which you can do the design and also you can do the runtime. In the design time, essentially you onboard the resources, you create a services, and then you create all these closed loop designs. So again, once you start getting into more detail, you will know how flexible it is in terms of being able to do a lot of these functions. So that's all in the design time. And the important part is that there's something called a catalog. So where you can create all these models and store them in the catalog. The advantage of that is that it becomes reusable. So let's say you create a model and you push it to the catalog, and another developer or another user wants to use something similar, they can just use that. As long as you publish it as an open item, they can reuse it. So that is the advantage of this model-driven architecture. And finally, when you're done with all of this, you distribute the model, and then it goes to the runtime, which picks up all of these models, and then it has something called service orchestrator, which is the main component of the runtime. And that allows you to create instances of this model, right? So there are a few other components, and I'll briefly talk about them. So there's something called active and available inventory in ONAP. So that's a single source of truth in ONAP. So essentially, everything that you do in the system, all the models you create, all the instances that you create, how they are related to each other. So they're all maintained by the active and available inventory. So essentially, that's one place where you can go to get all the information about your deployment. So that's the single source of truth. And then, of course, there are controllers for doing the SDN infrastructure that I just talked about. And lastly, there's a module called data collection analytics and events. So what it does is, it's called DCAE, stands for data collection analytics and events, that allows you to collect events from your infrastructure or from your XNFs. And then you can run some analytics on those events and take some actions. So if you remember, I talked about the service assurance, right? So that's essentially what service assurance means. So you can take events from these XNFs and then do some analytics on that and take some corrective actions. For example, if there are so many errors, you do this. Or if your load is so much, you do this, right? So that is, so you can create those types of policies so that the automatic actions can be taken without really writing any new code, right? Because the whole idea is that you don't want people to start writing code to develop, change the behavior or add this functionality. So all this can be done by some kind of a descriptive policies that even a non-programmers can do it. So that's the whole advantage. So that's a very quick overview of ONAP, what the functions are. Now let's talk about the external interfaces and what are the different ways that you can interface with ONAP. And some of these interfaces are aligned with MEF and TM forum specifications. So it's not 100% alignment because some of them are still work in progress. For example, there are some TMF standards where it is aligned, some it's not, but it's a work in progress. So the OSS essentially enables you to do the capacity management, supply chain management, handling failures, providing the KPIs, right? So it provides an interface for it. For example, vendors may have their own OSS portals, right? Where they can allow you to see the KPIs, look at the errors, change the add additional capacities. So all of that is done through these OSS layers, right? And these OSS layers can interface with ONAP using the well-defined APIs. Right? So that is the interfacing that needs to be developed, right? So the other is the billing side, right? The BSS. And again, similar to that, the billing information, the user events, SLAs, all of them can be either configured or reported on the BSS platforms. And again, the BSS platforms can interface with ONAP using these well-defined interfaces, right? So that's the role of these OSS BSS layers and how they interface with ONAP. And then you can perform all the functions that are required for the end user or the operators. Now, so we've seen a very high level overview of ONAP, right? So now what are the ways that you can customize ONAP, right? So there are multiple ways, right? So at the lowest layer is creating models, right? So I already talked about how you can create models in ONAP, right? So it enables you to add VNFs or CNFs, create services, add policies, recipes. So these are all the models that you create in some kind of a modeling language, right? And then you can onboard them on ONAP, right? So that doesn't require you to add any code in ONAP, modify ONAP, reinstall ONAP. You don't have to do any of that. So you can have a running system and then you onboard all of these models, right? And this doesn't require a lot of any programming knowledge or in-depth understanding of ONAP. So you can just do it by understanding how the ONAP, VNFs are structured and so on. Right? So the next level is using ONAP SDK. Right? You can develop analytics applications, data collectors, dashboards. So these are some of the functions that are already present in ONAP, right? But let's say as a user or as a developer, you want to enhance them. You want to add some new analytics functions, or you want to have a, some proprietary way of collecting data, right? Or you want to create some dashboards that are specific to your organization, right? So you can develop all of them using the ONAP SDK, right? So this will require some programming knowledge, right? So, and then the last model or the last layer is ONAP code itself, right? Because ONAP is completely open source, right? So any organization or any individual can contribute to ONAP. They can fix bugs, they can review commits, they can add new functions, but you have to be part of the community to do that. And there is a process for doing that, right? So these three layers are roughly in the order of complexity, right? The lowest layer, the models, are the easiest way to contribute to ONAP, because you don't really require deep understanding of ONAP. You don't require programming knowledge. So you can develop all of these models using the modeling languages, right? The second level requires some programming expertise. And the third level requires some deep expertise of ONAP. Right? So each one has its sort of increasing complexity. Okay. But the message of this slide is that you can contribute at different levels without really being a programmer. So, and lastly, the ONAP will take some effort, right? So ONAP is not something that just works out of the box, right? So you go install ONAP and then nothing happens, right? Because it doesn't, by default, it doesn't do anything, right? So it's like a platform. It's like installing a operating system on your computer, right? So unless you install some applications, it doesn't really do anything, right? So the same thing with ONAP. So it's like a platform. So when you install it, you have to do certain things to make it do something useful, right? So, and this is what this slide tries to identify. What are the things that you can do? So one is VNFs. So you have to either develop VNFs, or you have to get them from some vendors and onboard them. And then you have to create services out of them. And then you have to either use some of the workflows that are already present, or you have to create some new workflows, policies, collectors, analytics applications, OSS, BSS interfaces. So again, all of these are functions that you will have to do on top of ONAP, right? And again, some of them are already existing in ONAP, so you don't have to develop everything from scratch, right? But if you want to change them, for example, you want to create a new service, which is currently not there in ONAP, right? So you have to create that. Similarly, if you want to change some workflow, which is already there in ONAP, so you'll have to either write a new workflow, or you have to modify an existing workflow, right? So these are the things that need to be done to make ONAP do something useful. So it takes effort. It's not something that where you can just install ONAP and expect something to happen. So this slide just gives a very high-level overview of some of the alignments. So those of you familiar with the MEF and the TM forum, there are some standards. For example, MEF has Allegro, Legato, Interlude. So again, ONAP has some alignment with some of them. Similarly, with TM forum, there are some standards which ONAP implements. Some of them are work in progress. Some of them are fully So this talks about the history of ONAP. So ONAP has been there for close to 4 or 5 years. So it started in 2017. The first release was Amsterdam. So in fact, ONAP releases go by alphabetical, right? So it's A, B, C, D. So Amsterdam, Dublin. So it's a city name starting with an alphabet, right? So the current release is actually even beyond this. In fact, the current release is I release, which is Istanbul. So this slide talks about Quilin, which is the last in December 2020. And after that, there were 2 more releases, H release and I release. So this talks about the Honolulu release, which is the prior release. So just to give a flavor of who are the contributors, how many commits happen. So it's a very, very, very active project. A lot of contributors, a lot of the companies, most of the telcos in the world, across the world, are part of ONAP project. So they have teams that are contributing at different levels, of course, and in different components. So just to give a flavor, 30 organizations, 24 projects, 151 Git repositories, 207 authors, and roughly 3,000 commits. So it's a very, very vibrant community, very active community. And in terms of the percentages, these are some of the companies that are the active contributors. So now let's just talk about some of the use cases. Even though it talks about Frankfurt release, it's applicable to all the releases. So some of them are applicable directly for telcos. Some are generic, can be used by enterprises for other applications. For example, there's a virtual firewall and virtual DNS, which is a standard. It's an open source version, which is present in ONAP. So this is probably the easiest one that somebody can try out if they want to start using ONAP. And then there are a couple of these residential use cases, VCP and BBS. There is another one, OLT. Again, it's a voice over LTE. It's not, so some of them are, by the way, not open source. So you will not see them in the, when you actually check out from the ONAP public repositories. So you may have to talk to the commercial vendors for some of them. Some are open source that you can use. Similarly, there's a CCVPN use case for slicing and MDance. There's a 5G, which is very popular now because of the interest in the 5G. So this gives a flavor of each use case. Again, we don't have time for every specific use case, but essentially the firewall is a very simple virtual firewall demo. It's more like a demo. It's not a production use case. So it shows you the entire life cycle of a VNF, how you can onboard a VNF, how you can create a service and a policy, and then you distribute it. And then you go to the runtime and then you do a deployment. And then you can see it in action. You can see that there's a traffic generator, there's a firewall, and then there's a sink. And you can see that the traffic is flowing through the firewall. So you can see that simple application. And you can also create a closed loop with the virtual firewall. So that's another example that's there in the open source ONAP. So it's a very interesting closed loop application where it receives the events and then takes some action. And based on that, on the action, it actually reduces the packet rate from the packet generator. Right? So you can actually see the closed loop in action, where without any manual intervention, you can see that the packets are generated at certain rate. And then over a period of time, when they cross certain threshold, automatically there's an action that is taken so that the packet rate stabilizes. So that's a closed loop automation that you can see. And essentially with this application, you can see the entire ONAP operation. And this is the simplest one for somebody to get their hands dirty and try it out. So VCP is again a little more complicated. There are multiple VNFs in this. Again, it's not a production CPE. It's an open source CPE, which you can instantiate on your own app framework and manage it. And all of them are open source components, so you can actually try it out. It's based on the Fido project, fd.io, and the VPP projects. Similarly, there's a broadband service. Again, some of these are not open source, so these are proprietary that you will have to work with a specific vendor to instantiate them and to use them. So again, all of this virtualized BBS service can be created using this blueprint. So once you have the license for these proprietary components, ONAP will allow you to create a service, instantiate them. Similarly, VoLTE. So it's a proprietary service, but once you have the license for all of these components, you can use ONAP to orchestrate and instantiate them and start using them. And by the way, all the vendors that you see here, ZTE, Huawei, Nokia, all of them have done the integration with ONAP already, right? So these blueprints are pretty much ready to use. So you can just take all the models that are created and start using them, assuming you have the license to use the proprietary components. Yeah, so there's some of the other use cases. For example, the CCVPN is another use case where if there are two telcos, how they can be interconnected over two different domains. So the idea of this is that ONAP can be used for sort of inter-domain communication. So in this particular example, there are two different vendors, two different telcos who have used ONAP. So each of them have their own ONAP installation, and they communicate over the MEF interlude interface, and each one can orchestrate their own network functions. So MDance is again another multi-domain optical network service. It's again a proprietary service where ONAP can be used to orchestrate them, start up all of these different network services and so on. Lastly, 5G. So there are multiple vendors who have developed 5G, which are either virtualized or containerized, though we see a lot of them using the containerized framework for 5G. So again, ONAP allows you to orchestrate them. For example, 5G has multiple services, right? AMF, SMF, PCF, and you can orchestrate them on either one or multiple clouds. You can create networks between them. You can do all of the lifecycle management. You can upgrade them. So all of the starting from orchestrating them to managing them to deleting them, you can do the entire lifecycle management with ONAP. So there are a few other things which are more detailed. Some of these network services provide configuration interfaces over multiple interfaces. Some of them provide netconf, some of them are over REST interfaces, and ONAP supports all of them. So there are components in ONAP using which you can configure something over netconf or a REST interface. Similarly, another important aspect is the ORAN, right? So again, that's a completely different topic that we can go into later, but essentially ORAN is a software community which ORAN SE is a software community which is implementing the reference architecture for Open RAN. Right. So, and ONAP can interface with the components. In fact, ONAP implements some of the components required for ORAN. There is a component called SDNR in ONAP, which implements the SMO functionality of ORAN. So probably the last one is the network slicing. So this is again another use case that's getting a lot of attention, and ONAP supports network slicing, which essentially enables you to take the multiple domains in, for example, in a 5G network, and create multiple slices out of that. Right. So this is one of the very important use cases for 5G, right, where you can take a single pipe and have multiple slices with different SLAs potentially. Right? So, for example, you can create one slice that is used for virtual reality applications, maybe another slice for industrial sensors, right? One for drones, one for maybe some emergency services, and each slice may be optimized for different use case. For example, one slice could be optimized for high bandwidth. Another could be for very low latency, right? So you can have different characteristics for each slice. So now, what is the role of ONAP in this, right? So ONAP will allow you to create these slices, activate them, and modify them, right? You can do the lifecycle management of these slices. For example, when you create slices, you may have to change the characteristics of the slice. Right? So ONAP allows you to do all of that, and it has workflows to do all of these functions. So next, I just want to briefly touch upon the collaboration between ONAP and ORAN SE community. The ORAN SE essentially is an independent community, software community. But there is a lot of collaboration between ONAP and the ORAN SE community, right? So, for example, ONAP implements some of the functions that are required for ORAN specification. For example, SMO, right? So these are implemented by the ONAP, and then also some of the SDNC layers in ONAP are enhanced to a project called SDNR, and that is the module that implements the SMO functionality. So that's where this collaboration comes in. Now, lastly, what have we been doing as a company? What is Arna's role in all of this? So essentially, what we do is we provide a commercial support for a subset of ONAP that we call as AMCOP. So essentially, AMCOP is very functionally similar to ONAP. It does everything that ONAP does, but it uses only some components of ONAP because we focus only on certain use cases, right? So that's what we do. And the specific use cases that we are focusing on are 5G and Edge. So again, the technology ONAP is very generic. You can use it for multiple use cases, right? But the functionality that we support in Arna is specific to 5G and Edge use cases. And for that, we picked some of the components from ONAP. Again, I will not go into the detail because unless you are familiar with ONAP projects, you may not be familiar with it. But essentially, these are the projects that you see in ONAP that we are actively participating. So we contribute, and we also use them. We support them as a commercial distribution. So if somebody wants to productize it, essentially they can come to us, and we provide a commercial distribution for this. So think of it as a Linux analogy, right? So Linux is open source, but there are companies that build commercial distributions for Linux, like Red Hat and so on. So we are something like that. So we take the open source ONAP and then we provide a commercial distribution for a subset of that. So that's what we do. And as part of that, we have done a lot of hardening of some of the components to make them usable for a production deployments. So lastly, how do you get involved in ONAP, right? So again, I mentioned in one of the previous slides. So there are essentially two ways you can get involved. So one, as a developer, right? As a developer, you can start with ONAP wiki page. So I have references to that. You can join the community. It's free. It's open. Anybody can join. You can read about all the projects. You can join the mailing list. You can even join the calls, the weekly calls that happen. You can download the tools. You can read about integrating with ONAP. You can attend the events, which are again, open events, right? So these are all the things that you can do as a developer. Now, as a user, again, you can join the community. You can start deploying ONAP. You can try out different use cases that I mentioned, virtual firewall, virtual CPE, and so on. And of course, as you gain expertise, you can get more and more sophisticated with all these use cases. So these are the ways that you can get involved with ONAP. So this has some of the references to ONAP documentation. Again, the project is open, so it's available. There's a wiki page. There is a read the docs reference site, which is mentioned on the slide. So you can look at all the documentation. You can download it. You can install it and try it out. So that's the so there is a ton of information that's available to learn about it. So I think that completes the presentation on ONAP. And if there are any questions, we can certainly I can help answer.
Sriram, excellent presentation, very thorough presentation, starting from the ONAP beginning to end. I really enjoyed. Now, on behalf of our faculty members who will be going over it, I want to ask you what kind of research activity this can generate for them. Is there any specific areas you think where there is a opportunity for researchers?
Absolutely. So there are multiple areas where depending on the interest, they can participate. So one area that kind of readily comes to mind is there is a ton of work that's happening on the analytics side of it, right? The AML, right? So ONAP itself doesn't support, it's not a machine learning platform, right? But it has ability to ingest or take some of these AML models, right? So if someone is doing research on optimizing some of these networks, for example, there is work going on with it's called SON, self-optimizing networks, right? So networks that can fix its own problems by looking at the events and doing some analytics, right? So there's a lot of research going on as part of the machine learning and so on. So that's probably one area where there is a lot of scope for research. And the 5G, of course, is a new area where there is a lot of research going on. So again, ONAP is, so one thing to keep in mind is ONAP is a management path. It's a control path, right? It's not a data path. So if someone is working on the, let's say, 5G data path, it may not be directly relevant for ONAP, right? But ONAP enables them to orchestrate them, place them in multiple networks, create, service meshes. So if someone is doing research in that area, creating service meshes and so on. So that's another area which is where we see, a lot of scope for, for additional research.
The answer is very excellent. So for the research folks, you pointed out it's plainly pure control plane and maybe management plane, but none of the data plane, but they can use it for the ORAN, Open RAN, 5G, and obviously AIML. These are the areas which they should
Absolutely.
focus on.
Yeah.
Now, given that this is a open source and there are some closed source also proprietary, how do you, because some of the documentation mentions a lot of things and sometimes you don't get to know what exactly is open, because unless you go trace to the key end of it, you don't know whether it will work or not work. So how do you generate a bomb to know beforehand that, okay, I need to have this modules which are proprietary? Is there any description anywhere about every use case which you have discussed, or is it just we have to go through the documentation and figure out one by one?
Yeah. So the first thing is, as a platform, the entire ONAP is open. So there is nothing that's closed in ONAP itself. Okay. So the only commercial part of ONAP is if you really want a commercial support, right? Where you go to companies like us and they might charge for support. But as a platform, it's completely open. It's open source, right? Now the proprietary components are essentially the net virtual functions or containerized functions that run on top of ONAP. So ONAP orchestrates them, right? So that's where some of the ones that I mentioned, for example, the ZTE or Nokia or any of those virtual functions, right? So those are proprietary, right? So I think the way to look at it is that the platform is all open, right? It's there's nothing that that's closed in that. So you look at your use case. If your use case requires certain commercial functions, that will require commercial license. So you will have to account for that from a budgeting point of view. So that is the separation. So the platform is open. The artifacts may or may not be open.
Excellent. So definitely that's one thing to consider. And the other part which I wanted to add to that is, do you have any ONAP version which researchers can adopt or utilize for their projects, which may or may not be commercial in the sense, because they may be trying to do some research, trying to write some patent, or trying to do some simulation, or doing some kind of a emulation. I don't know, but I'm thinking you must have something which is for academics. Do you have any academic version? What kind of support you have for that?
So if you're talking about specific ONAP, so ONAP releases are, they happen every 6 months, right? They can take any of the ONAP releases. Probably I would go with the latest release, install it and try it out, right? So, but there is no ONAP distribution that is meant just for somebody to, for doing their research, for example. There is no such thing, right? So ONAP is a standard commercial or rather it's a community version. And there is no vendor who will support ONAP as a complete distribution. There's no commercial vendor who supports the full ONAP distribution, right? So we are one vendor, but we support a subset, right? But the community version of ONAP is available. I think that's what I would suggest as a starting point. If somebody wants to try it out, take the latest version. For example, now the Istanbul version. There is a documentation on how to install it, and it's all free, right? So they have servers in their lab, just set it up, set up a Kubernetes and install ONAP. So that is the quickest way to get started.
Excellent. So
then once they gain expertise, what they can do is, depending on their area of focus, they can install only a subset of components.
Yeah.
Instead of the entire ONAP.
I get your point. So try taking a community version and installing it, and it is based on some cluster, Kubernetes cluster. Do you need one cluster, N cluster, any specific requirements you're aware
No,
of?
one cluster is enough. The resource requirement is quite high for ONAP. So if you want to install full ONAP, you require if you're going with one server, it has to be a fairly powerful server. For example, 36 core type server, right? That's kind of the minimum that you require. And you can have multiple servers. For example, if you have a 16 core server, maybe you need 3 of them, right? So that is the bare minimum requirement for running ONAP. But again, as you gain expertise, you will know how to customize it, how to take only pieces that you need. Then you don't need such a heavy resource.
To some technical stuff about the workflow, especially workflow is based on the blueprints, and blueprints are of variety of forms, right from TMF forum to the Metro. You get in YAML, you get in netconf, you get in so many varieties. And is there a specific recommendation for choosing the templates for ONAP installation, not the functions I'm talking about, for ONAP? Is there any blueprint which we can adopt to deploy the ONAP platform or a Kubernetes cluster? So we are beyond cluster now, we are talking of ONAP platform.
So for ONAP, for deploying ONAP, you don't have to develop any new blueprints, right? So ONAP has its own, Ansible mechanism. So you just run. So once you have a Kubernetes cluster, you run the Helm commands, and it deploys ONAP with all its components and so on, right? Probably your question is more on after deploying ONAP, what kind of workflows are things that you can take a look at, right? So
you got me right. First is you got the clusters. Second, you got the ONAP platform using Ansible. Third, when we come to the TMF forum or using something from the Metro Ethernet or whatever MFR and whatever templates. Example, let's say we want to deploy 5G, voice over 5G, VO, not the VoLTE, but voice over 5G, a new module, let's say. What would be the steps you would recommend in this case? Where would we go? Would I go to TMF or would I go to Metro Forum or I go to ONAP or ORAN? Where do I go for this? If this is a new, how would it?
Yeah, so for creating models and for deploying them, you actually don't have to go to any of them, right? So ONAP itself gives you a portal. So think of ONAP portal as a, your sort of a simplified OSS portal, right? So it allows you to create models, and then you can onboard them, and then you can go to the runtime part of the portal. It's called VID, and then you can see all your models. For example, taking your example, right? Let's say 5G. So you create a 5G with RAN and everything, right? So you create a model, then you can go click on it and say, I want to instantiate it. So once you instantiate it, it'll actually create all the necessary network functions on the target cluster, either OpenStack or Kubernetes or wherever you want to deploy them, right? And those workflows are already there in ONAP, so you don't have to develop them. So the common workflows that are required to do some simple operations like instantiating and so on, so those are already present in ONAP. So you don't have to develop anything new. Where you have to develop the new workflows is, for example, you have your own OSS system, right? Or and then you want to create some kind of a interface with ONAP, where you want to interface with, for example, a vendor has an existing OSS system, and they want to interface with ONAP. So there you may have to customize some workflows or develop new workflows, right? But for a beginner, that's really not required, because ONAP itself gives you a portal for doing all the common operations. right? I don't know if I answered your question, but
Yeah, you did answer the question. I would put it this way: what you are saying, alluding to, is that for simple VNF onboarding and all, you do have something, and for the runtimes, you do have something already. So the
correct.
question is, what's your application? If it is a telco-centric application and telco is driving it, then telco has to provide that. But if it is not
Correct.
telco-centric, if it is, example, university-centric, which is what I was trying to allude to. If a university wants to maintain its own, let's say, example, say Wi-Fi and Wi-Fi 6E, Wi-Fi 6G, those are which are not existing yet and which they want to experiment using with ONAP as the management model. And they may include some Magma modules, I don't know, they may include that. So if such a thinking is there, how would ARNA help? Do we need to have some MOU? Do we need to have engagement? What is your model of uh, working with the academics specifically? That was what I was trying to try to.
Okay.
Because they do research, they want to do something research, and they want to not get into doing a lot of things which you already have. Why would we reinvent the wheel, right?
Mm-hmm. Yeah, so the way we can help is, so like I said, there are multiple layers in ONAP, right? So one is the ONAP as a distribution, right? So if they want something that's production worthy, we can help with that. The second part is as a professional services, right? So let's say they want to customize some workflows or create new workflows for example, the Wi-Fi example that you have, right?
Mm-hmm.
So we can help in the professional services aspect because we have a lot of expertise in building these workflows, creating these models, right? So that's where we can potentially help, and you get a lot of help in the community also. I mean, it's not that you have to come to a vendor for it. For example, you can join the ONAP community, and there's a lot of discussion groups and stuff. But then, in the community, it's a best effort, right? Yes. So you can post a question, and if somebody's available, they will answer. Otherwise, they may not. So, but the commercial vendor, we can give a sort of a guaranteed service. That's the only difference.
Yeah, the reason, because academics suffers today, there is no hand holding like what the commercial people have. And they definitely can afford to put the kind of uh, effort and resources to make it happen. Academics, what happens, a PhD guy sits there for 3 years, he gets something, and by the time he's done, he moves on, and there is nobody to take over further action. And so the challenge, which every foundation, Linux Foundation also does the same thing. We have to maintain, and so we need some kind of a intermediate. That's the thinking, and certainly I'll come back to you offline. But
sure.
Let's now see here. There is a design model which is available for anybody to build the model. So first thing is you have to build the model. That part is understood. Then after that, you have to have some way to test it so that you can do in the community whatever best you can. And then when it comes to having the professionals or commercialization of it, that is the time when we should get to you to be able to make a win-win situation for the player who is there as well as yourself and the entire community.
Yeah,
I think I got you, and I think you have covered very, very widely, because I remember it started with harmonization when I was the Mano chair during that period in the OPNFE. So
right.
it's quite a and obviously there is a lot of versions. I version is like now you already have covered almost a dozen versions. So what I see is this is a very good time to take off using Mano, and we certainly will encourage our faculty to at least, when you say Mano plus plus, you do have management network orchestration plus plus. What those plus plus are like design plus you got the containerization stuff, and those are the things which they should
Service
integrate.
assurance.
Service assurance. Yes, service assurance, that is monitoring and then controlling back in the closed loop. Yeah, those are the things which we want to have our faculty people to understand, and do ask questions, and we will do offline with Sriram once I will close this at this time, and I should thank pretty much Sriram having taken over from Amar, because we had asked Amar and then he stepped in the right time. And we are very thankful to both Amar and to Sriram to have done a very good job from Arna Networks. And we definitely owe you a token of appreciation, and we'll do that. Thank you very
Sure.
much, and appreciate. Take care. I'll close with this, and rest of it we'll do offline questions.
Okay.
Thanks.
Thank you.